Hi everyone, my name is Nick from Copy Before Arch, and in this episode of Python 3 Crash Course, we are going to be doing our first step into object-oriented programming. So you may be wondering what object-oriented programming refers to. So it typically refers to these things called classes. And classes are very useful things in programming. What we'll look at today specifically is that classes can be a very useful thing to do something called encapsulation. So if we have many different things that all relate to, say, one large thing, we can encapsulate it all into one specific class. So everything in Python really is classes. So, integers have a class, lists have a class, and we can call things from those classes. So when we get the size of a list or on a string, if we call, say, reverse on a string, or rather if we call we make a string uppercase or lowercase, or if we do any kind of if we do anything like that, we're calling a method, and that's because somewhere there exists a class for strings where they have defined methods. So it turns out we can define our own. So in this case, we'll open up simpleclass.py, and in this case, we'll do a coordinate class. So very simple. A coordinate will be a 2D coordinate right now, so we'll just have x and y. And so we create our own class, which you can think of as a data type if you like, and this will be a coordinate. And so all we have to do is use the keyword class and then coordinate. Then over here, we'll define this init right here with 2 underscores. And what this init is, it's a method that we use to create an instance of this class. So when we make when we set something equal to a class, we have to make it. So in this case, it will call an init function. And so in this case, we'll have 2 variables. We'll have x and y that we'll pass in. And then the self refers to this instance of the class. So you can think of it as, we take a class whenever we're we're creating a new instance of a class. So we'll say C1 is equal to coordinate. Now, what that does is it plops down a new version of coordinate, a blank one, and then over here it'll call init to fill it up. So over here, self refers to this new coordinate that we plop down. And then x and y refer to just some things that we're passing in from the outside to initialize this new coordinate that we plop down. So in this case, we'll say that for this specific coordinate, so self.x, that will be our local data attribute. So for this coordinate, I want to set this version of this coordinate's x equal to whatever you passed in. And then I want to set this version of y, this coordinates version of y, equal to the y that you passed in. So self.x and self.y refer to the x and y that correspond to this particular object, while the other x and y refer to the numbers that get passed in. So we don't just have to have this default initialization, or rather we can do a lot more things than just have, initialize a new object. We can also do some interesting things. So maybe we want to see what's the difference between 2 different coordinates. So what's the space between them? So in this case, we'll define another method that we'll just call distance. We can call it whatever we want, but distance makes the most sense here. And we'll say it'll take 2 arguments. It will take self, referring to this class, and then we'll take other, so another coordinate. So is what this will be called with. So it'll find the distance between 2 different coordinates. Now here, we'll just use a simple Pythagorean theorem. So a squared plus b squared is equal to c squared. We want to find the distance between 2 different points. So we'll find the difference of x squared. So we'll subtract these 2 things and take raise it to the power of 2. And then same thing here, right? So we'll square this, we'll apply it to the power of 2, and then what we'll return is a squared plus b squared, and then we'll take the square root of that, which will give us just c, and then we'll do that by taking it to the 1/2 power. So to the 1/2 power is the same thing as taking the square root. So that'll give us a difference the distance between 2 points. Now, you may have also wondered, okay, what if we want to say, what if we want to print out a class? So we just call print on a class. Well, it's going to give us something pretty nasty if we don't do something kind of special. It'll tell us, you know, a memory location and say that this class is from the main function. So what we'd really like to do, though, is we'd like to have, when we say print on a specific class, we'd like it to do something useful. And so what a class will print out, or when you call print on a class, what will print out is this built-in underscore string str underscore. And so we can change this by defining it ourselves to mean something. So in this case, instead of printing out something kind of jumbled that doesn't give us, you know, any intuition of what a coordinate is, we can instead write our own. So in this case, we'll just say, you know, left less than sign, and then we'll have self.x, comma, self.y, plus, and then the right closing greater than sign. And so it'll just basically print out this coordinate instead of saying that this is an object in the main function at some memory location. So we can make it a lot more useful. So there's a lot of other things we can override too. Maybe if we want to add things together, so we can override add. Same thing, we can override what subtraction does, as well as equality, less than, or rather equals, less than, and length. And there's many more that we can override. So this is just if we want to have our own specific implementation that we want to redefine what add means in the context of these classes. So let's go ahead and see how we actually instantiate a class. So if you want a new class coordinate, it's very simple. We'll just do the class name, coordinate, and then our input parameters, so 3, 4. Now we don't need to pass in self here because self is automatic. It refers to the class that we're creating. So in this case, self is this coordinate C1, so we don't need to pass in self. Now here we can also, we'll also make another coordinate that will just be the origin. Right, so pretty simple. So over here, we'll go ahead and print out the X and Y fields, data attributes in each of these classes. So in order to access those data attributes here, so this self.x and self.y, all we need to do is take the class name and do .x, and then the class name, C1.y, and that will give us access to these data attributes of the class. So, and we'll do that for both the C1 and origin. Now, we'll go ahead and also print out the distance with explicit and implicit parameters. So if we want to find the distance between two things, remember, up here we define that to take self and other, and then it would do the Pythagorean theorem. So there's two ways we can call this. We can use explicit parameters, so we can say, okay, I want to call the method from coordinate distance, and then just like we call a function, methods are called the same way. We use the parentheses, and then I want you to find the distance between C1 and origin. So that's one way to call it. Now the other way to call it is implicit, or we can call it with an implicit argument, and that's if we call it from one of the classes itself. So not just our class definition of coordinate, but if we call it from C1, we can do C1 and then dot distance. Now the self will now refer to C1, so we don't need to pass that in as an argument. All we need to do is pass in what we want to compare to. So in this case, origin. We want to find the distance between C1 and origin. So two different ways to do the same thing. And then over here, we'll just print out a class object, and it will use our redefined version of underscore string underscore, where we just print out self.x and self.y. So that's going to do it. Let's go ahead and run this. So we'll call Python3 on simpleclass.py. So here we have our instance of coordinate called C1 that will be 3 and 4, and then have x equals 3, y equals 4, and then a coordinate origin. X is equal to 0, y is equal to 0, and then we'll find the distance using explicit parameters, which is 5. Now you could work it out in your head, so 3 squared plus 4 squared is going to be equals 25, and then if you do square root of 25, it's going to be equal to 0. Now, of course, 3 minus 0, 4 minus 0 is just 3 and 4 respectively, so we don't need to worry about the difference in this case. And then, of course, it uses our custom string. Now, let's go ahead and see if we print an object, but we get rid of this definition of a custom string right here, right? So what if we didn't have a custom string? What would happen? See, it prints out this main.coordinate object at some nasty pointer. So it can be really useful if we want to have something meaningful when we print out a string. It can be really useful if we override this underscore string. So that's going to do it for today. That's a very simple introduction to classes. They can be incredibly useful because we can store all these like things together. So instead of having to have 1,000 variables inside of our script that say x1 equals something, y1 equals something, x2 equals something, y2 equals something, we can cut that in half and just have coordinate 1, coordinate 2, coordinate 3. So it can be a way to concisely represent things. So if we go ahead and go to github.com/coffeebeforearch, we have all the previous videos, links to all the previous videos, as well as all the code for all of my series, including the Python, C++, and GPU programming with CUDA crash courses. And then also my lecture slides and links to the videos for my video series on computer architecture research called This Week in Architecture. So for us, we looked at Python3 crash course. So here's my contact information, my setup, and then links to all the previous videos, the concepts covered in those videos, and the files that we used. So today we use fundamental concepts, classes, and then we use simpleclass.py. So feel free to download this, check it out, make it your own, play around with it, and let me know if you have any questions. So as always, I'm Nick from Coffee Before Arch, and I hope you have a nice day.